Friends, welcome to the class. Today we'll discuss some questions on circles. So let's start. The first question states PA is a tangent to the circle with center O. If BC equals to 3 cm, AC equals to 4 cm and triangle ABC is similar to triangle PAO, find OA and OP by AP. Let's draw the picture first. So given PA is tangent to the circle with center O, and BC equals to 3 cm, AC equals to 4 cm, and triangle ABC is similar to triangle PAO. Now, in triangle ABC, BCA equals to 90 degree because the angle in semicircle here, AB is the diameter of the circle, and so angle C is the angle in a semicircle. So therefore, angle C is 90 degree. So AB square equals to AC square plus BC square following Pythagoras theorem, or this implies AB square equals to 4 square plus 3 square, which is equals to 24, or that AB is nothing but 5 cm. Since O is the center of the circle, OA is nothing but whole AB by 2, or it is nothing but 5 by 2 cm. Also, given that triangle ABC is similar to triangle PAO, so we can write AB by AC equals to OP by AP, or OP by AP is nothing but 5 by 4. Thus, OA equals to 5 by 2 cm and OP by equals to 5 by 4 is the answer. In the given figure, PQ is a tangent at point C to a circle with center O. If AB is the diameter and angle CAB equals to 30 degree, then find angle PCA. Let's draw the picture. Given PQ is a tangent to the circles with center O, AB is the diameter of the given circle and angle CAB equals to 30 degree. That means this particular angle is 30 degree. Construction, OC is joint. Now, OA equals to OC because the radii of a circle. Angle OCA equals to angle OAC because angles opposite to the equal sides. So this implies angle OCA equals to 30 degree. We know OC is perpendicular to PQ because the tangent to a circle is perpendicular to the radius and the point of contact. Here C is the point of contact. So we can write OCP equals to 90 degree. That means this total is equals to 90 degree. Now OCP equals to OCA plus angle PCA. So both are equals to sum total of these two angles equals to 90 degree, or we can say PCA equals to 90 degree minus angle OCA, which is equal to 90 degree minus 30 degree, which is equals to 60 degree. Thus, angle PCA equals to 30 degree is the answer. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. So let AB is the diameter of the given circle, and LM and PQ are the tangents drawn to the circle at the point A and B respectively. We need to prove LM is perpendicular to PQ. Proof: we know that the tangents at the point of a circle is perpendicular to the radius to the point of contact. That means OA is perpendicular to PQ and OB is perpendicular to LM. Or since OA and OB are the two parts of the same diameter, so you can write AB is perpendicular to PQ and EB is perpendicular to LM. Or this implies angle PAB and angle LABM equals to 90. That means PAB is this angle and angle ABM is this angle. They both are equals to 90 degree, but these two angles are nothing but the alternate angles. Or this implies angle PAB equals to ABM, and Both of them are nothing but the alternate angles. So this implies PQ parallel to LM, hence proved. In the given figure, PQR is a tangent to the circle with center O at point Q. AB is a chord parallel to PR and angle BQR equals to 70 degree. Find angle AQB. Let's draw the picture. So given that PQR is a tangent to the circle with center O, the point of contact is Q. AB is a chord parallel to PR and angle BQR equals to 70 degree. That is this particular angle BQR equals to 70 degree. It is already given. This AB is parallel to PQ or PR you can say, and Q is the point of contact with the center of the radius. Sorry, center of the circle. Now angle ABQ equals to angle BQR equals to 70 degree because this is angle ABQ and BQR and nothing but the alternate angles as these two are the parallel lines. So triangle ADQ and triangle BDQ. In triangle ADQ and BDQ, we have DQ is a common side. Angle ADQ equals to angle BBQ, which is equals to 90 degree, because AB is parallel to PR and DQ is perpendicular to PR, or AD equals to BD. So this implies triangle ADQ is congruent to triangle BDQ by SAS congruency. Or this implies that QAB equals to 70 degree. Now in triangle ABQ, angle AQB equals to 180 degree minus QAB plus QBA, or it is nothing but 100 degree minus 70 degree plus 70 degree, which is nothing but 40 degree. Hence, the value of angle AQB equals to 40 degree is the answer. In the given figure, XY and XY this are the two parallel tangents to the circle with center O with point of contact P and Q respectively. Another tangents AB with point of contact C intersecting XY and XY at points A and B respectively. Prove that angle AOB equals to 90 degree. Let's draw the picture. Given XY, XY' and EB are the three tangents to the circle with point of contacts P, Q and C respectively. Tangents AB intersecting XY and XY' at the point A and B respectively. We need to prove angle AOB equals to 90 degree. That means this particular angle equals to 90 degree. Proof. We know that the tangents drawn from an external point to a circle are equal in length. That means we can write AP equals to AC. Now in triangle APO and triangle ACO, in those two triangles, AP equals to AC, O is a common side, and OP equals to OC because the radii of the common circle. So this implies triangle APO is congruent to triangle ACO by SSS congruency. So, or we can write angle OAP equals to angle OAC. That means this angle and this angle, these two angles are same. Or we can write angle PAC is nothing but twice of angle OAC. This is first equation. Similarly, we can prove that angle COBO equals to angle OBQ. And this angle is equals to this angle. This can be proved following this method. That means if we make triangle OCB and triangle OBQ are congruent to each other, then we can find angle CBO is equals to angle OBQ. Or you can write angle CBQ is twice of angle CBO. Here this is the second equation. Since XY is parallel to X dash Y dash, PAC plus QBC equals to 180 degree, because this angle and this angle are 180 degree because sum of the interior angles on the same side of transversal is 180 degree. What this implies, you can write twice of CAO plus twice of CBO equals to 180 degree, or angle CAO plus CBO equals to 90 degree. This is third equation. That means this plus this. These two angles is equals to 90 degree. But in triangle AOB, sum total of all the angles is nothing but 180 degree, and the sum of other two angles is 90 degree. So it is clear. Angle AOB is nothing but 90 degree. Now in triangle ABO, triangle CAO plus angle CBO plus angle AOB equals to 180 degree, or angle AOB equals to 180 degree minus angle CAO plus angle CBO, root is nothing but 180 degree minus 90 degree, or this is equals to 90 degree. Hence proved. PA and PB are the tangents to a circle which circumscribes an equilateral triangle, triangle ABQ. If angle PAB equals to 60 degree, prove that QP bisects AB at right angle. Let's draw the picture first. So given PA and PB are the tangents to a circle, and the circle circumscribes an equilateral triangle ABQ. So, and also it is given that angle PAB, this angle PAB is equals to 60 degree. We need to prove QP bisects AB at right angles. Construction, that PQ is joined so that PQ intersect AB at the point M. Proof. Since ABQ is an equilateral triangle, we have angle QAB equals to angle QBA, which is nothing but 60 degree, because in equilateral triangle all the angles are equals to 60 degree. Now angle PAQ equals to angle PAB plus angle QAB, or this is nothing but PAQ equals to 180 degree, because already it is given that this angle is 60 degree, and as because this is an equilateral triangle, angle A or angle Q or angle B all are 60 degree. So this 60 plus this 60 is nothing but 120 degree. Similarly, we can get angle PBQ equals to 120 degree. Now, in triangle PAQ and triangle PBQ, we have PA equals to PB because tangents from an external point to the circle. PQ is a common side, and angle PAQ equals to angle PBQ. So we can say triangle PAQ is congruent to triangle PBQ by SAS congruency, or angle APQ equals to angle PBQ. Now in triangle PAM and triangle PBM, we have angle APM equals to angle BPM, PA equals to PB because tangents from an external point, and PM is a common side. So triangle PAM is congruent to triangle PBM by SAS congruency, or this implies AM equals to BM, and angle AMP equals to angle BMP. But angle AMP plus angle BMP equals to 180 degree, because this is nothing but a straight angle. So this implies angle AMP equals to 90 degree, because both sum total equals to 180 degree and both are equal. So angle AMP is nothing but 90 degree. That means this implies PQ bisect AB at right angle. Hence proved. The radii of two concentric circles are 13 cm and 8 cm. AB is the diameter of the bigger circle. BD is a tangent to the smaller circle touching the point D. Find the length of AD. Let's draw the picture first. Given radii of two concentric circles are 13 cm and 8 cm respectively, AB is the diameter of the bigger circle and BD is a tangent to the smaller circle, and the point of contact is D. Construction: BD is produced so that it meets the bigger circle at the point at the point E, and AE is joined. So now triangle AEB equals to 90 degree because angle formed in a semicircle. Also, OD perpendicular to BD, because BD is the tangent to the smaller circle and OD is the radius. Or we can write BD equals to DE, because B is a chord of the bigger circle and OD is perpendicular to BE. Or this implies, in triangle AEB and D at the midpoints of the side AB and BE respectively. So OD equals to 1/2 AE, or A is nothing but twice of OD, or it is 2 into 8, which is nothing but 16 centimeter. Now in triangle BOD, OB square equals to OD square plus BD square by Pythagoras theorem, or BD square is nothing but OB square minus OD square, or putting the values we get it is 13 square minus 8 square, which is nothing but 105, or BD is square root of 105, or BD is nothing but it is equals to DE, so DE is also equals to square root of 105 centimeter. Now in triangle AED, AD square equals to AE square plus ED square, or this implies AD square is nothing but AE square plus ED square, or it is nothing but 256 plus 105, which is nothing but 19 centimeter. Hence, AD equals to 19 centimeter. The answer. In the given picture, from an external point P, a tangent PD and a line segment PAB is drawn to a circle with center O. When is a perpendicular the chord AB? Prove that. The first one, PA into PB equals to PN square minus AN square. Second bit, PN square minus AN square equals to OP square minus OT square, and PA into PB equals to PD square. Let's draw the picture first. So given P is an external point, and from the point P, a tangent PT and a straight line PAB is drawn to the circle with center O. When is the perpendicular on the chord AB? Now first bit, PA into PB equals to PN minus AN into PN plus BN, because here PB is nothing but PN plus BN and PA is nothing but PN minus AN, or this implies it is PN minus AN into PN plus AN. Why? Because AN equals to BN, as ON is perpendicular chord on AB and ON bisects AB, or we can write that PA into PB is nothing but PN square minus AN square. Hence proved. Now come to the second bit. In triangle ONP, OP square equals to ON square plus PN square by Pythagoras theorem, or PN square equals to OP square minus ON square. Let this is first equation. Now in triangle ONA, OA square equals to ON square plus AN square by Pythagoras theorem, or OT square equals to ON square plus AN square, because OA equals to OT equals, as it is radius of the same circle. Let this is second equation. Now PN square minus AN square is nothing but OP square minus ON square minus AN square, because PN square is nothing but OP square minus ON square. This is from the equation 1. Or we can write it as it is OP square or minus ON square plus AN square common, but ON square plus AN square is nothing but OT square, as it is obtained from equation 2. Hence proved. Now come to the third bit. In triangle OTP, OP square equals to OT square plus PT square by Pythagoras theorem, or PT square is nothing but OT square minus OT square. Let this is third equation. Now, from equation 1 and 2, we got PA into PB equal to OP square minus OT square, because from the first bit we proved P into PB equals to PN square minus AN square, and in the second bit we got PN square minus AN square equals to OP square minus OT square. So we can write PA into PB equals to OP square minus OT square, or P into PB is nothing but PT square, because this is from the equation 3. Hence proved. If A, B and C are the sides of a right angle triangle where C is the hypotenuse, then prove that the radius R of the circle which touches the sides of the triangle is given by R equals to A plus B minus C whole divided by 2. Let's draw the picture. So given that A, B and C are the sides of the right angle triangle and C is the hypotenuse, the triangle circumscribes a circle with center R with radius R. Let the given triangle be ABC so that BC equals to A, CA equals to B and AB equals to C. Let the center of the circle is O and sides BC, CA and AB, and the circle touches the sides BC, CA and AB at the point D, E and F respectively. Construction OD, OE and OF are drawn. Now come to the proof. We know that the tangents drawn from an external point are equal in length. So we can write AE equals to AF, BD equals to BF and CD equals to CE. Now in quadrilateral OECD, each angle is equals to 90 degree and angle OE equals to OC. This OE equal to EC equals to CD equals to BO, because CE and CD are the tangents from the same point, so CE equals to CD, and OE and OD are nothing but the radius of the same circle. So that means the neighboring sides are equal in length and all the angles are equals to 90 degree. So you can say OECD is square. Now AF equals to AE equals to AC minus CE and BF equals to BD equals to BC minus CD. Or you can write AF equals to EE equals to B minus R and BF equals to BD equals to A minus R. Now AF plus BF is equals to B minus R plus A minus R, or you can write AB equals to A plus B minus 2R, because A plus BF equals to AB. Or this implies C equals to A plus B minus 2R, or on interchanging we get 2R equals to A plus B minus C, or R equals to A plus B minus C whole divided by 2. Hence proved. Prove that the parallelogram circumscribing a circle is a rhombus. Let's draw the picture. Let ABCD is a parallelogram circumscribing a circle. To prove ABCD is a rhombus, that means we need to prove that all the sides are equal, which is nothing but AB equals to BC equals to CD equals to DA. Proof. We know that the tangents to a circle from an external point are equal in length, so you can write AM equals to AP, BM equals to BN, CO equals to CN, and DO equals to DP. Now, AM plus BM plus CO plus DO is equals to AP plus BN plus CN plus DP, or this implies AB plus CD equals to AP plus BD plus BN plus NC, or this implies AB plus CD equals to AD plus BC. Let this is first equation. Also, ABCD is a parallelogram, that means the opposite sides are equal, or you can write AB equals to CD and BC equals to AD. Let this is second equation. Now from equation 1 we got 2AB equals to 2BC, or this implies AB equals to BC. Let this is third equation. So from equation 1, 2 and 3 we got AB equals to BC equals to CD equals to DA. That means all the sides are equal. We got a parallelogram where all the sides are equal. That means ABCD is a parallelogram. Hence proved. Friends, the questions that we discussed, many of the questions appeared in the previous board exams. So these questions will be helpful from your exam point of view. Keep practicing more and more such questions, and in case you come across any difficult questions, feel free to share the question with me. It will be a pleasure for me if I can help you out in solving your doubts and solving your question. So this was for today's class. Thank you.